Okay. Oh, there was a. See, it didn't work. Maybe it's the mouse or something. Let's shut this off too. Okay, so here you can see how they spend a lot of time designing these connectors and choosing what to background, what to foreground in the design. And if you look further in the thesis, you see what kind of design principles they were looking at. So the bricks should be portable, you should fit them in a pocket, they should be able to be left in the environment and things like that. So they had kids as the target users, and they were thinking of the use cases in schools that kids use for those devices. Same thing about the programming language. So here they are even thinking about, we should get rid of loops and ifs and just have an event-based programming where you have like, when sensor A less than 20, then do something. So these people, they were always thinking about how to make things easier for kids, how to background a lot of the complexity of programming and electronics, and really let kids explore the powerful ideas that they can do with robotics and all of that. So this is the model that they designed. So a lot of the circuitry goes inside this box, this board, the power, because it should be autonomous. And then we just connect motors and lights outside of it without much. But then there was another story going on in parallel with this. And this was the wiring model. And I was explaining what that is first. So this is the basic stamp, which appeared more or less at the same time as the first bricks from MIT. And this is a device for hackers and enthusiasts and electronic buffs to do electronics. And it's also a microcontroller-based device. So you can see just by looking at it that it's not that easy. It's hard to figure out where to connect what, right? There are many versions of this device, but it eventually. A graduate student at the Ivrea Institute, Hernando Barragan, came up with this board which used the processing programming environment, which is a very powerful programming environment created by two MIT students, and his own hardware design to make it very easy to access the microcontroller and do all kinds of interesting work. However, what they were doing, their concern was, how can we make this easier for interaction designers, for artists, and for undergrad and graduate students in this kind of interaction design programs to build devices and prototype. They were not really designing for kids. And the advisor of Hernando Barragan, whose name is Massimo Bunzi, saw this and really liked it and basically rebranded it into Arduino and launched it in 2005. And here, you can see that if you look closely at, those are the connectors of the Arduino. So this is like, digital PWM and TX, RX, and all these numbers. I mean, you don't really know what it does.